Station, this is Houston. Are you ready for the event?
Houston, this is Station. We are ready for the event.
West Sound STEM Network and South Kitsap School District, this is Mission Control Houston. Please call Station for a voice check.
Station, this is Dr. Karine Borders. How do you hear me?
Very well. How do you hear me?
We hear you great. Greetings from West Sound STEM Network. We have 1,000 students on site and 200 invited guests. We're all very anxious to talk with you today. Thank you so much. I'm going to turn it over to the students.
Well, welcome to the International Space Station.
Okay, we are going to begin with student questions now. Our first question is coming up.
My name is Lucas, and my question is, how do you clean the outside of the ISS?
Lucas, I'm happy to report that one of the tasks I've had is not to clean the outside of the space station. Luckily for us, because the environment has so little in it with which the space station interacts, the outside really doesn't get dirty.
Thank you.
My name is Shayla, and my question is, we studied yeast, cellular respiration, and fermentation by breaking bread in class. How does microgravity affect bread rising aboard the ISS?
That is a fantastic question. In fact, I'm very fortunate because Paolo Nespoli, an Italian astronaut, is on board the station with me now, and I didn't know anything about how to answer that question. Turns out he had been a baker when he was younger. So we talked about it for a while, and because bread rises because the yeast actually produces gases throughout the bread, because the yeast is evenly distributed in the bread, you end up with those small gas pockets throughout the dough. If we were to do that on the space station, we think it would be very similar because the dough is sticky enough that those air bubbles wouldn't move around very much. Unlike water on the Earth, where the bubbles tend to float to the surface, water in the space station wouldn't allow bubbles to float to the surface. There's not really an up that would be defined. But the dough would be sticky enough that the bubbles wouldn't really be able to move. Maybe we'll be able to do an experiment on that someday.
Hello, my name is London Coates. Thank you for your time today, sir. Recently, I've been reading about space junk, and I was wondering if you had ever seen any while you've been on board the ISS, and how does the station take evasive action?
Another fantastic question. So I personally haven't seen any space junk directly, and I'm very happy about that too, because everything's traveling at high speeds in orbit, so if they're traveling in a direction other than ours, I want it to be as far away as possible. Which is why NASA has what we call debris avoidance maneuvers, where we will actually reboost the orbit of the space station in order to avoid debris that we know about. Another thing that we've done, though, is made the exterior surface of the space station something that can resist micrometeorites. I can tell you that in some of the photography where we take a picture every second or every half a second, we've actually picked up flashes of light where a micrometeorite interacts with the atmosphere and burns up in the atmosphere. So we know things are out there. We've captured imagery that shows that things really are out there.
Hello, our names are Emma and Sydney, and our question is, what research are you currently working on that you think will have the biggest impact in our lifetime?
That's another great question. I'm definitely speculating because there's lots of different venues that could result in incredible discoveries. But what I'm particularly excited about is our combustion research on the space station. My hope is that as we learn about how to to use combustion to make things move, and understand combustion better so that we can burn fuels more efficiently, that because we're so dependent on combustion for the way we use energy right now, that may have a very big impact on our lives in the future.
My name is Ronan, and my question is, what does the endless void of space feel like?
The simple answer is it feels very, very big. When I did a spacewalk and we opened the hatch of the space station to go outside, and light reflecting off the Earth came inside, it got very, very bright. And when I went outside and was in the sun, it was an amazing experience because there was nothing between me and the Earth except for my spacesuit. And being able to look away from the Earth and towards the stars, when all the bright lights from the Earth, all I could see was blackness. So it was, the scales are kind of hard to comprehend, as probably the best way I can describe it. It's just a great sense of immensity.
The next two questions are coming from students in the state of California that I'll read for them. The first student is Julian Templanza from Steve Luther Elementary School in Cypress, California. Julian's question is, I know you grow plants on the ISS with artificial light. How does the light affect the plants, and does it result in a different taste or look?
So my impression is it does not result in a different taste or look at all. And the light affects the plants because the light grows toward, the plants grow towards the light. Again, there's no up or down, so that's what they use to figure out where to go. And honestly, they do that on the ground as well. And maybe it was because I've been away from fresh produce for so long, but the Mizuna, that's a type of lettuce that we had on board after we grew it on board, tasted incredibly good.
The next question is from Kuhu Gupta in California. Kuhu asks, since there is no up or down, how would a helium-filled balloon move around in the ISS?
Very much like on Earth, except for the exception of this effect from gravity. So on Earth, the primary forces on a helium balloon would be the mass being transferred out of the balloon, which would cause the balloon to travel in the opposite direction. Then you have, which would be called a thrust force. You have the force from gravity pulling it towards the Earth. And then you also have air resistance, which can make the path be unpredictable as the balloon changes shape and the air resistance pushes it in different directions. On the space station, we still have the air resistance. We still would have the thrust. So we just wouldn't get that curve towards the Earth that the balloon would tend to happen on the space, that the balloon would tend to have in the vicinity of the Earth. It still happens in space because we're all curving towards the Earth. We're just going so fast we miss it. But in the confines of the space station, it would look like it's not falling towards either the floor or the ceiling.
My name is Maya, and what do you miss most about Earth?
I think the thing I miss most about the Earth is my family, and a close second would be feeling sunshine and wind.
My name is Addie, and my question is, where and how do you sleep on board the ISS?
It's a great question. We all have a sleeping bag. It's kind of a neat sleeping bag. Our sleeping bags actually have armholes. So, and my sleeping bag happens to be attached to a wall, just like this one, inside of what we call our crew quarters, which is kind of about the size of a closet. So I zip myself in the sleeping bag, and my arms can hang out of the sleeping bag while I sleep, just like this. It kind of just holds me in place so I don't float around while I'm trying to sleep.
My name is Acacia, and and my question is, do the stars look different from the ISS than from Earth?
So you get the clearest view of stars on Earth when you're in a place that tends to have less moisture in the atmosphere and less light to interfere with your ability to see the faint lights of stars. On the space station, if we turn out the lights in the space station, and then, of course, we don't have any humidity outside the space station because it's the emptiness of space, we can see really, really well. But one thing that's nice about the Earth, if you're in a desert, for example, you can look from horizon to horizon, see stars everywhere you look. For us on the space station, unless I'm doing an EVA, I can only see the stars through a pretty narrow window. So I think I can see more stars on the space station, but the view is over a more limited range.
My name is Charles, and my question is, if the ISS was damaged, how would you safely evacuate?
Another great question. I'm happy to say that we have the same vehicle that we launched in to get to the space station, stays docked to the space station, and serves as a lifeboat the entire time we're here. So if we had to abandon ship, we have a means to get home in about 5 hours.
My name is Kylie, and my questions are, what has NASA discovered about bacteria in space? How does this impact your daily life?
So inside the space station, we have about the same types of bacteria as you would have in a very safe home. The space station is very clean. But we have some evidence that shows that in space, bacteria tends to be more resistant to antibiotics and also can be more virulent. How does it affect my life? Every Saturday, I have to clean up the space station just like I would at home, and we have chores to do up here to make sure we keep the space station clean and don't get an overabundance of bacteria.
My name is Mia, and my question is, what advice would you give a middle school student who wanted to be an astronaut?
I would say figure out what you love to do and try to find a way to do it for a job. NASA hires all kinds of people from a broad variety of fields, but they're very successful in those fields, and doing something you love is a great way to be successful at it. Of course, it also needs, if you want to be an astronaut, it also needs to be a field that's a technical field. So make sure you go to college and get a degree in something like a physical science, computer science, things like that.
My name is Isabel, and my question is, what medical skills are astronauts required to have in case of a severe injury in space?
I'll tell you one that we trained for. In fact, there's a backboard here in case we had to give a fellow crewmate CPR. We're trained how to use an AED and even to give medicine to help restart somebody's heart if necessary. The other thing we do, of course, NASA screens its astronauts very carefully to make sure we're healthy enough that the chances of that are very slim. But another thing we have to do is be able to understand the directions that doctors would give to us if we ended up in a situation where we didn't know what to do, because we have lots of help on the ground that can advise us on what to do.
Hi, my name is Becca, and my question is, what is the scariest thing you have experienced while exploring the unknown in outer space?
I would say being outside in a spacewalk was the scariest thing. It's an environment where you have to pay very close attention to everything you do for multiple hours. And there's a lot of redundant systems to make sure you're safe. But it's a situation where you have to really be careful to not just protect yourself, but also to make sure you don't break equipment that people have invested a lot of time in making sure is up in space doing the things we needed to do.
Hi, my name is Aspen, and my question is, how did your body, mentally and physically, first react when you flew and arrived into space?
Another great question. When I first got to space, I was in one of those Soyuz spacecraft, a Russian spacecraft. And when we first were really in orbit, when we were no longer being accelerated by a thruster and only falling through space around the planet, it felt kind of like being at the top of a roller coaster, a fast roller coaster, when you get to the top and it starts going back down, where you kind of rise out of your seat. Except when I've experienced that on the ground on a roller coaster, that was a very momentary feeling. It was a strange feeling for me because I kept feeling like the spacecraft was falling away from me when really I was just floating inside of the space station, inside of the spacecraft. When I got up to the space station, it kind of felt like someone was holding me up by my feet a little bit because my bodily fluids tended to float towards my head. And I was a little uncomfortable. My nose felt stuffy. And psychologically, I was very excited. I was amazed at how big the space station was. I just never saw all the pieces in a simulator put together, and it is much bigger than I really envisioned. It was also a little stressful, as you can imagine, because I had to get to work, and there's a lot of visibility on the work we do up here.
My name is Cutter, and my question is, what are your thoughts about the upcoming commercial crew flights to the space station?
My thoughts is that it's a thing we need to have be successful, and I'm looking forward to it starting to happen. It's something we've been trying to get going for a long time, and I expect it to be successful, and I look forward to it happening as soon as possible.
My name is Piper, and my question is, what was the most difficult challenge you faced in getting where you are today?
The most difficult challenge for me definitely was learning how to be a co-pilot on a Russian spaceship. My commander is great, but having to take classes on a lot of technical devices in a foreign language was very challenging. And knowing that if I made a mistake, it could affect the lives of my crewmates was something I took very, very seriously.
My name is Riley, and my question is, what changes on our planet can you see from space? And what does this tell you about where I should live in the future?
So having only been up here for between 2 and 3 months, the biggest change that I've seen has been a change of seasons. In the northern hemisphere, I'm starting to see more of the ground covered with snow. I don't think that's really what you're looking for, though. I can tell you what surprised me the most. What surprised me the most was how much, when I see rivers pouring into the ocean, how much you can see the colors changing from all the sediment coming from the rivers. I don't know that that's a big change or how long that's been going on. I'm sure I know that as long as there's been rivers, there has been sediment traveling down those rivers to the ocean. I don't know if that's been increasing over time or not, but I know it's something that surprised me with how noticeable it is for me from space.
Hello, my name is Corbin, and I was wondering how drinking a carbonated beverage is different in space and whether or not microgravity will affect the carbon dioxide levels.
So I don't think carbon dioxide levels would be affected by microgravity. What affects us here in space, though, is that we're in an enclosed environment. And since human beings are producers of carbon dioxide, we actually have to have a system to scrub it out. The end result for us is our carbon dioxide levels are higher here on the space station than they would be on the ground. As far as carbonated beverages go, I would expect the expansion of gas bubbles compressed under pressure when that pressure is released to behave the same. However, I think carbonated beverages on the space station would be a bad idea because it would make a big mess. And I haven't seen one on the space station. I don't know that it's impossible, but I certainly wouldn't want to have to open one up and have anything fizzy heading out the straw.
Space Station, a big thank you from West Sound STEM Network. We really appreciate your time, and it was very inspirational.
Thanks. It was a pleasure talking to all of you today, and I hope you have a wonderful afternoon.
Station, this is Houston ACR. That concludes the event. Thank you.
And thank you to all the participants from West Sound STEM Network. Station Houston, we're resuming operational audio comm.